Hello, everyone, and welcome to episode 134 of Dial the Gate. My name is David Reed. This is a special episode for me. It's something that I've been wanting to put together for a while now. Stargate consultant, Stargate's fangirl, and real-life astrophysicist Mika McKinnon, who was on set as the science consultant for Atlantis and Universe, is joining us along with Rodney McKay himself, David Hewlett, to discuss Stargate science. We have several topics that we're going to discuss for the first half of the episode. In the meantime, on youtube.com/dialthegate, our moderators are taking your questions in the live chat to David and Mika that I will ask them in the second half of the program. So I appreciate you tuning in, and I think we're going to have a eye-opening discussion. I think it's going to be very interesting, some of the topics that we're going to come up with. But before we get started, if you like Stargate and you want to see more content like this on YouTube, it would mean a great deal if you click that like button. It makes a difference with YouTube's algorithm and will help the show continue to grow its audience. Please also consider sharing this video with a Stargate friend. And if you want to get notified about future episodes, click the subscribe icon. And giving the bell icon a click will notify you the moment a new video drops, and you'll get my notifications of any last-minute guest changes. And clips from this live stream will be released over the course of the next several days on the Dial the Gate and GateWorld.net YouTube channels. So as this is a live show, we have our guests on with us live. This is not pre-recorded. So again, you can submit your questions at youtube.com/dialthegate to the moderating team who will submit those questions over to me. And then I will pick some of the better ones. This is a Stargate science specific episode. So I'd like to keep the questions as much as possible geared in that direction. And without further ado, let's go ahead and bring in our guests for this episode. Mika McKinnon, science consultant, Stargate Atlantis, Stargate Universe, David Hewlett, Rodney McKay, all of Stargate in general. Hello, sir. Hello, ma'am. How are you?
It's like real genius and fake genius.
We're just not going to clarify which way around that goes.
No, I think it's pretty apparent, I think.
Mika, how are you? How are things going? It's so good to have you back.
I'm doing well. I'm having fun. I've got my whole little collection of rocks just out of scene. I've got excitement to be able to talk about all of our on-screen science instead of real life doom. Doing fictional doom sounds way better right now.
Jeez.
Fictional doom's always so much more pleasant, isn't it? And it's also much more visually pleasing.
Yes, and there's all these things where you can be like, absolute worst thing that can happen, and then make it worse and worse and worse, and nobody dies in the end. It's perfect. I love it. It's like the ideal form of disaster.
And someone steps in, does a lot of talking, and then solves it, and it's done. It's great.
Well, I mean, there are reasons like Dante's Peak is a great film. I mean, in terms of like a disaster movie, I think that's the quintessential disaster film. You've got James Bond against a volcano, and so theorizing allows us to create things like this, watching them on television without actually experiencing them in person.
I guess that's it. I wondered if it was going to change because of the pandemic. I wondered if people were going to want like more, but disaster still seems to sell. So
Absolutely. I remember when the pandemic first started, and I started seeing copies of Stephen King's The Stand fly off of shelves everywhere, the miniseries, and it's like, really, seriously, is this? I guess people just like to scare themselves.
Well, remember when we couldn't get a copy of 1984? It was like about 5 years before that. Everyone was like 1984 was like it was off the shelves. You couldn't find it anywhere.
Just craziness.
Oh, it's my big only consulting project during the pandemic so far was for Moonfall. So I am definitely seeing the interest in having over the top catastrophic disasters.
Yeah,
was definitely there.
I liked
Moonfall
it.
I thoroughly enjoyed it, but it was so ridiculously silly.
Oh, absolutely, it is.
Yeah.
I was very, very excited because, first of all, like it's the king of disaster movies, right? Like bucket list item for a disaster geophysicist being like, yes, let's do that. Let's
creator of Stargate. Yeah,
exactly.
For sure.
And I got to
Roland Emmerich we're talking about, just for those who don't.
Yeah, and so I'm a science consultant in the film industry, and one of the things I get to do is it's effectively like being a one-on-one science tutor for the writers and the directors to be like, them say, hey, here's this world or this story, this environment, and my job is to go, let me tell you more, let me teach you the science, let me give you all these extra ideas, which direction do you want to take your story in? And one of the chunks of how I was saying, okay, so here's what we know about the moon and how we know what the internal structure of the moon is in geophysics, we say things ring like a bell when you have an earthquake, because it makes the entire surface, it's acoustic waves. So that we go, oh, it rings like a bell for a couple of days. And that line made it into the movie. And I'm like,
wow.
So that made me very, very, very happy.
In reference to a hollow moon, admittedly.
Yeah, that's okay.
Yeah,
Sure.
yeah.
It's during, the Apollo missions, they did do seismic experiments. They had little seismometers on the moon.
Well, and aren't they launching? They've got a whole bunch of new. One of the things they want to put on the moon now is new versions of those, right?
Oh, it'd be so fun. And there's currently one on Mars. So the Mars InSight lander has seismometers on it, and it was that we tried to send a seismometer there with the Viking missions, but it was on the top of the rover, lander, and it blew in the wind. So it was a really good weather station, unfortunately.
Right.
And it took about 30 years to land one 3 feet lower on the surface. And just this last week, it detected the largest earthquake ever on another planetary body.
Wow.
So normally it's been detecting things that are like the equivalent of magnitude 3, which is like if a truck passes your house and it rattles a little bit, that's what a magnitude 3 would feel like. This was a magnitude 5, which is if a truck ran into your house, or like a giant punched the side of your house is how that would feel. So pretty cool.
I love this whole sensor thing. Like there's been such a boom in the creation of sensors that and that combined, like I'm so excited about the next like 10 years for space because there's so much stuff that we're going to get within the next like decade that's going to come to fruition that I'm like so excited to go to the internet every morning because there's always something.
There's always something new to learn. Mika, so I have to ask you, as being a consultant on Moonfall, is there no chance in hell that the moon is hollow on the inside? We know that for a fact.
We are very, very, very certain what the moon looks like on the inside. We're very good on that fact that it is solid.
It's solid rock.
Not only is it solid, but the top surface of it. So on Earth, the crust is like, it's the flexible yet solid thing coating the Earth. The plate tectonics moving around. Everything moves at like the rate your fingernails grow, and that's why we have earthquakes. On the moon, the crust still exists, doesn't move, no plate tectonics, but instead of being mostly solid, it's actually been shattered because there's been so many things banging into it over the years. And we know that because of how the earthquakes move through it, that the seismic signals are all chewed up and reverberate as if it's like on a gravel beach or something.
Oh, wow.
So like we have a really good idea of what that looks like.
And does it have a core? Like, does it have a magnetic core like we? Because surely not as strong as ours.
It's not really magnetic because it doesn't have that liquid core. So center of the Earth. If you watched The Core in the 90s,
I love that movie.
I was there too. Yep.
Yeah. Turns out it actually has a really good Geology 101 lecture where they go, hot metal moving fast creates an electromagnetic field. So the structure of the Earth, kind of like a peach, they do the demonstration in that particular movie. We've got the thin little crust that we all hang out on, and that's like as far as we've actually ever been and physically seen. And then everything else we know from geophysics, which is what my specialization is. And geophysics is like a cross of like James Bond villain and MacGyver, in that you go around to these exotic places, you like land a helicopter on a glacier or something like that, put out all of your fancy equipment, try not to get like bears chewing on your cables, and then you push a big red button and you do something to disrupt the planet. You shock it with 2400 volts of electricity, you blow up explosives, you do something, and it creates a signal. It goes through the Earth, and you get the signal popping out the other side. And it has changed in between. So it's a Douglas Adams Hitchhiker's Guide to the Galaxy. You have the answer. What was the question? Like you've got the 42. What did it need to get that question in the first place? That is geophysics. That's the entire science of geophysics. So from that, we know the entire interior structure of the Earth because we can see things like how fast the earthquake waves travel through, and based on their speed, we know what type of rocks they have to be. And we know that there is a liquid outer core and a solid inner core on the Earth because some types of waves only go through solids. Like if you're in a swimming pool, you can shove water at somebody, but you can't like wave water back and forth at somebody. So if you do like a jump rope, you can wave it back and forth and you can get that side to side, that shear wave. You can't get that in a liquid. So we see the shear waves disappear as they're traveling through the Earth, and then they pop back out again on the other side. So we know there's that liquid inner core, outer core.
So we can infer
like
that based on what we're observing.
Yeah. And it's like it's so close to being magic, but is actually mathematics, and I love it. And it's just bonkers the things you can find out. During the pandemic, we could actually tell what countries had lockdown when and how well people were following them because we could see it on our seismic stations.
Oh my God, seriously?
Yeah, I was part of a big team of geophysicists like all around the world. There was, I think, 100 of us looking at our seismic stations during lockdown, the papers in Nature. And it's the global quieting where just everything suddenly went.
Yeah, we're not driving our vehicles anymore.
Yeah. Not driving our vehicles, not landing planes, not way lower pedestrian traffic. We didn't have the cruise ships, like none of them. It was amazing. And then
how were you getting that data though? Were you getting that data by just working it out yourself, or was this AI doing this stuff? What was the
the seismic stations are always recording because we want to be able to look for earthquakes and also for nuclear bombs. That's why we have a seismic network.
I can't imagine why.
Better fire those suckers up again. Yep, right.
Yeah. And then now there's this huge advent of people using Raspberry Pis to make little at-home seismic stations.
I love Raspberry Pis. I got like 6 of them. Yeah.
It's ridiculous what you can do with them.
Is a shake and boom is you can attach effectively a 3-dimensional microphone to it, and that will be your seismic station. And then boom would be doing an infrasound monitor to it if you wanted to check for explosions. But those are all over the world, and they're just run by people at schools, at museums, in their home, whatever. Mine is.
I could just like put one in my backyard.
Yeah, and then you just release the data, and you're like, surprise!
Oh, that's great.
But because we use them for outreach, they tend to be like in the city core. So we can really see it super, super clearly on all of those.
Oh,
and we just look for the background noise that we're always trying to filter out so we can look for earthquakes. And instead we're looking at the background noise and we're able to see that it was all just
quiet. I wouldn't have even thought of that. That's amazing.
So cool. Yeah.
Huh.
It was a collaboration that started on Twitter because geophysicists were being like, hey, look, my station got really quiet. Anyone else see that? And so I seemed like, yeah, LA, totally silent.
Wow.
And I found that super reassuring in those early days of pandemic when it was like really lonely and it felt like nobody was like, you'd look out the window and see people going about their lives and you're like, but I'm behaving. And you get this reassurance that actually, no, everybody is in this together. It's a lot less reassuring now.
Of course, weirdly, I was in the film industry, so we were actually out blowing things up in the fields. So that was, I was on sea. We were literally blowing up things in fields.
But you were doing it safely. So.
Oh God, yeah.
With every precaution known to man at that time.
Oh my God, yeah, like testing every like second hour. It was like crazy. My nose has never been cleaner.
Wow.
Yeah, I filmed 2 different documentaries during that. And one of them was like, it was the camera person and the sound person with me, everybody masked up. Yeah. I'm not. Yeah. And then like everybody else was like on an iPhone watching.
Yeah. Oh yeah, we had like on sea, our showrunner was like basically like a phone that walked around, I mean, it was always, I much preferred actually when he was on set, which is weird. That's not usually the case, but yeah, it was like having it was like having a human cell phone avatar just sort of walking around.
You're like, we totally need those little robots doing that now, the like remote access
ones. Well, so I was reading about that with exploring the moon, was that apparently they've started, which I was like, I never understood why they always sent these big robots out. But I was like, why don't they just send a little one? Now apparently they've got little ones now, little RV type things that can drive around and get data for us as well, which is kind of exciting.
When are we gonna deploy these things?
I think it's like, well, get told.
Okay.
So one of my research project right now, I'm with Project Espresso, it's a NASA funded project where I'm with SETI. So technically right now I'm a SETI scientist.
Sweet.
In case you ever wondered about extraterrestrials. That's my current job. So Project Espresso, one of our like the big overarching goal of the project is to create a tool set where you can put it on the side of robots and have it be in orbit around a comet or an asteroid or a small moon or something and go, where is interesting, where is safe, let's find the overlap in the center, land there. And I'm on team where is safe, looking at landslides on these like comets and asteroids and things.
Oh, amazing.
But we also have a little rover that we're building out, and we're trying to use as an outreach rover where we want to put all of our tools that you would use on it, because we want to make science more accessible, right? Like science should be for everybody. It's the basic concept of science is be curious and learn about your universe. There's nothing that says you have to do X, Y, Z in order to be a scientist.
Right.
But doing geoscience, there's this huge bias that you need to do field work. And that's a big limitation. If you have physical limitations, if you're a parent and have care responsibilities at home, whatever it is, you can't go out into the field. But if you look at planetary science, all of our field work is done by robots, right?
Yeah.
Like the Curiosity rover is a geochemist. InSight is a geophysicist. Juno around Jupiter is another geophysicist. So we're trying to make this robot where you can like have your classroom log into it and direct it around an outcrop and like take samples and do a little spectrometry and do like photography or whatever else. So we're working on that. Hopefully it's going to be doing another test run in June. I don't know if I'm going to be able to go or not. It kind of depends what happens with the little baby vaccines and crossing the border.
Right. Yeah, of course.
So in theory, at some
rules on that
point,
now?
you in your classroom could rent time on this thing and go on a field day.
If it's NASA, then you get to do it for free because government funded, yo. It's like there should be public services. You shouldn't have to rent things. And
well, I mean, like renting
another
time
barrier
out.
to field work.
Yeah, you would have designated
like
time.
Huge expense, right? Like it's hard to do field work unless you got the money to go somewhere.
Well, we've sort of grew up at a time when it was sort of the way it was presented was that only these large organizations could do this stuff. And it feels like more and more recently we're seeing more DIY homegrown stuff. You see like little personal satellites and stuff. I mean, I'm so excited about that because as a non, as just a nerd who's interested in this stuff, the idea that people could actually take part in it without actually having to be, a part of these giant organizations or corporations or whatever it is just, I just find that absolutely, it's just
accessibility is broadening.
Yeah.
Yeah.
And there's the concept of what does it mean to do science, right? Like, so at its core, science is you come up with an idea of how you think things will work, cause and effect, and then you do experiments to see whether or not they happen. All right, what happens every time you revise a recipe for your favorite chocolate chip cookies? Right? Like you have a theory on this recipe will produce these characteristics of cookie.
Small burnt things in the oven for me. Yeah.
Yeah, it's chemistry.
And then like once you've eaten the cookie, you revise your recipe again by longer cooking time, shorter cooking time, more butter, less oil, different ratio of white and brown sugars, whatever else. So every recipe book is actually an experimental logbook. But we don't talk about that because how dare we think that cooking, a traditionally feminine task, can be science, a traditionally masculine task, even though like the earliest scientists' computers were all women doing math. So,
right. Yeah, you guys were the early computers. Exactly. Yeah.
My grandma was a computer.
It's funny. The recipe thing is interesting because there was a little lecture about problem solving, like how do we teach kids problem solving for the future? And one of the things it said was the most important skill to have is the dealing with failure, because failure is a way for you to learn something. If you don't fail at something, you've learned nothing. So the idea of like what happens when I screw up a recipe, I blame my son, kick the dog, and get angry, but that doesn't help. If you go, okay, so what do I do next time that will fix it? That's what you want to teach the kids going forward. It's amazing because my understanding of recipes was like if you followed it perfectly, it was going to work every time. That was it.
If the recipe's right, but also you have your own equipment that may be a little different too.
Exactly, like your oven might be off. You might be like. Recipes are written for being at particular temperature and pressure, which is not going to be true if you're at elevation. It's going to depend on what ingredients are available in your location.
And what the hell's roughly chopping?
How big is this really?
Yeah, what the hell? Give me a size for roughly chopped.
Pinching, like a pinch of something, right? Like non-standardized recipes, having different unit conversions, all sorts of things. But I mean, there's all sorts of ways that science is in everything. I mean, another one would be like knitting is applied geometry and algebra, because you get like a particular, and it's binary code. Knitting is a Turing complete programming language, so you can do anything with it. So just tactile programming.
How do you get anything done at home? Like I would feel like you're just like doing science experiments all the time.
Well, what else is life, right? Like, I think that I understand how my day is going to do. Science is like the most powerful tool there is. It's all right. So again, let's kind of go to the depressing aspect of, let's look at the world around us right now in the middle of a pandemic with ongoing climate change and worsening climate, like weather-related disasters every freaking year. Like
and killing each other
wherever you are, have your emergency kit ready, because wherever you are, this next couple of months of weather are going to be terrible again, because
California's already got wildfires now, right? Isn't that they've already started California, the wildfires?
And I'm up in Vancouver where Stargate filmed, and last year we had a heat dome of the hottest temperatures we've ever had. We had floods, we had fires. We had landslides that literally cut Vancouver off from the rest of Canada for a while. We had a meteorite strike. It was small. It was very small, but we did have one. We had a tornado, like everything. Just everything.
We had a truck rally. That's all we got. We got a truck rally.
That too. Yeah, it was fun. It was fun. But because we have science, we have this capacity of going and imagining. We understand cause and effect, or we can figure out cause and effect. We have a process for determining cause and effect, which means we can imagine any future we want and take the steps to get there. So it turns into a question of will as opposed to a question of capacity,
right?
Which that's a like moment of optimism with all the doom is.
Well, I want to explore something that I thought was absolutely stunning, and that Dave actually wanted to bring this up. We have our first photos as of just a couple of days ago, our first photos of Sagittarius A, which is the massive black hole that we have been orbiting since time immemorial. I'm going to pull this up here so that everyone can have a look at it. This is truly amazing stuff here. This photograph of this thing that we are orbiting. And how long does it take for us to complete an orbit of this, Mika?
Oh, it takes a very, very, very long time. Like, if you want to, like, we have not, the dinosaurs were still around before we made a complete orbit around.
Oh, wow.
And are we looking like straight at it or something? Like it's almost like we're looking down the eye at this point.
Yeah. And so my coolest piece of completely useless, no application science about this
Best
is the
science
black
ever.
holes are totally messy eaters, right? Like, they're gobbling things down. They're worse than toddlers. They spray gas and shredded stars all over the place. And that's what we're seeing, is we're seeing everything around it.
Wow.
That nebula, Sagittarius B, smells the same as raspberry rum.
Really?
Yeah.
How do we know that?
So we can we do spectroscopy. Anytime you want to look at stars and figure out what they're made out of, you take the light from them and split them into rainbows, and you look at the rainbows, and where you have little black lines in those spectra tells you what elements are present there. So that's how we know, like, what various stars are made out of. Is by looking at the light. That's all of astrophysics, is looking at light and trying to understand what on Earth is doing and how it's getting there.
Are they also big drinkers? Is that how that gets there?
Well, yeah, of course, right? Because fluid dynamics of alcohol won't kill your grad students and is relatively cheap. So you can do a whole bunch of things with that. I personally did it for volcanoes for the most part, so I can do like really fantastic cocktails that
the flaming shooters. You're good at the flaming shooters.
The volcanic eruptions, or doing the evaporative mixing of doing like a hard liquor with a heavy cream on top. Is actually, I did that during a Stargate wrap party.
Did you? That's always a mistake. Any shot with cream in it is just a mistake.
I was just doing science experiments. I wasn't drinking them. I was just like,
oh, you were drinking it.
Take a look at the cool evaporative patterns, because it makes a little fractally like webbing going on. Science experiments, man. How much cream can you get? But yeah, so we totally look at booze and figure out what's going on with it. But then we start trying to figure out, what do various places smell like based on what their chemical composition is. And unsurprisingly, Uranus actually does legitimately smell like farts.
No, seriously?
Yeah, seriously.
Oh, that's great.
There's something beautiful about that realization.
Yeah, Uranus smells like farts. That just sounds perfect. Yeah.
it's just true. It's the universe has come together the way it should.
Yeah.
The Milky Way galaxy smells like raspberry rum.
Oh,
Wow.
raspberry rum. I like the smell. That sounds. I like that just like that makes you want to drink.
Yeah, like we need a sci-fi series about a field astrophysicist who has to like go around and travel to these various
That's
places
funny.
and like poke the gas clouds, be like, huh, I wonder what that is. Lick.
Oh my gosh.
I've been brushing up. I've been basically learning about. I'm obsessed with molecular biology right now, and there's a whole thing in one of the crash courses about the guy who I can't remember the guy's name, who was basically experimenting with urine. Like that was just he was obsessed with urine and how this product was going to explain how our bodies worked and everything. And one of them was how it tasted. And I was just like, all of a sudden I felt that I perhaps didn't have the dedication that other molecular biologists might have in that situation.
It's going to taste like urine.
Yeah.
Generally speaking, so there's that whole thing about which sciences can you lick. I'm geo, so definitely you can lick some of the science and not other science. Some is very, very useful to lick. Like it's a great way of identifying which evaporates you have. You can do grain size detection, all of that. There's some rocks you really, really shouldn't lick. Anything brightly colored, turns out that is heavy metals that are really toxic. So like cinnabar has it's bright red and has mercury in it. Don't lick.
Right.
Any of the really, really bright green uranium-based minerals, again, do not lick. That's like just a bad move. But
it's like needs to be a
biology,
book. Like, do not lick.
Yeah,
Right.
biology, universal, do not lick.
Yeah.
Oh, jeez. I have a list of a few questions that I came up with here that I wanted to throw at Mika, and so the Daves could bounce their feelings and thoughts off of. Rodney went through the wormhole countless times, but I was always wondering, were this thing real, Mika? Would we need some kind of containment vessel to prevent being ripped apart, considering what we know about these things and what we can theorize?
So there's a whole bunch of different ways of creating wormholes in terms of what style you want. In Stargate, we use traversable wormholes using a short child radius. So we wanted it to be a specific size. And the real key trick to them is that you need negative energy density in order to make them happen. And what negative energy density means is you take vacuum and then you suck more out of it. And then surprise, you've got negative energy density. Scientifically works out, mathematically works out. Engineering problem, little bit of an
How to
issue.
suck the vacuum out of a vacuum? Yeah.
How can you get nothing from already nothing?
Just a teeny tiny engineering problem, but I'm a scientist. I don't need to solve the engineering issues.
Are people trying?
Else's issue.
Are people trying? I mean, there must be people trying, or
well, I mean, that particular one would require a whole lot of energy to get to the point where you can get negative energy density. But that was like the basic building blocks of the Stargate wormholes. But they had a lot of radiation to go with them. In part because you're
that's why I'm losing my hair.
There we go. It was too much wormhole travel over time.
That's it. Yeah.
So that would be the challenge of that. We could come up with a couple other ways of doing it, and we did actually have we did experiment with what could other wormholes look like, or sometimes in the background equations, and we did things occasionally like we fed the energy of a solar flare into a black hole in order to get time travel,
right?
Which does, like, those are equations you can all fit together. There is nothing that breaks in the physics of that.
Wow.
It's just, why would you ever do it?
Well, save Kennedy, of course.
Well, of course. And that for time travel to work, you need to be traveling through space as well. But something I really, really love, this small, tiny little detail, is that in order to have time travel make sense, you can only get 2 out of 3 things. You can have cause and effect. This thing happens and then that thing happens. You can have time travel where you change the order of events and time can go backwards. Or you can have the Doppler effect. So red shift, blue shift, or like when an ambulance goes by and it
Yeah.
goes, woo, right? With the pitch shifting, you can get 2 out of 3 in order to have a physically consistent universe. So in Stargate, we don't have the Doppler effect for the most part. And we cheated that in one episode. But aside from that one episode, we don't
have
the Doppler
writers.
effect at all.
Right.
That's how we solved the problem with writers. Yeah.
Okay.
Totally works.
So we would need special equipment, you think, in order to get through?
To protect us from radiation and stuff?
Yeah, because if we're going to release radiation.
It depends on your health and safety standards. I mean, you can do most things once. And it would not like shred you as you go through. You wouldn't have to deal with like the spaghettification of dealing with black holes. But it's kind of like how the sequel to The Martian is everybody dies of cancer. That's kind of like the long-term issue with traveling through Stargates too much, as everyone's life expectancy gets lower. We might have issues like in the real life space programs, we actually limit how long astronauts can, how long they can do flight missions because they have a lifetime radiation exposure limits. So same sort of concept on that.
And basically, as soon as you're out of the atmosphere, you're toasting, right? Is that basically it?
Yeah. And like as
Earth.
soon as you get outside of, so every time you see Northern Lights or Aurora Borealis, that is happening because you have charged particles from the sun hitting the Earth's magnetic field. The magnetic field of the Earth it's a shield. We have a giant shield that our planet very happily gives us. And if you go outside that shield, then suddenly you get bombarded by all those charged particles. Wow. And the space station is inside the magnetic field of the Earth, but the moon is not. So during the Apollo missions, there was actually one of the backup plans was if there had been a coronal mass ejection, if the sun had burped and sent charged particles towards the Earth and given us a beautiful light show of Aurora Borealis, it would have also baked the astronauts. And there would have been just kind of like a,
sorry, we overcooked the astronauts.
Yeah, like whoopsies. And that's one of the major problems when we're talking about sending humans out into deep space exploration or even to the moon, is that we need to have some sort of radiation shielding going on.
Is there radiation shielding on the space station? There must be to some extent, isn't there? I mean, because it doesn't need it.
I mean, like,
it's only 400. What is it? 400 kilometers up or something?
Yeah, it's still inside the Earth's magnetic field, so we don't have to worry about the charged particle aspect of it.
Okay.
Although they go over the Northern Lights and the Southern Lights, so you can see like the beautiful green blankets underneath.
It's so cool. Yeah.
But they have to worry more about collisions with things, so they have like blankets of Kevlar on the space station.
Yeah, especially now with the Russians blowing up satellites and stuff. Not making it easier.
One of the biggest causes of damage to other satellites is paint flecks.
I've heard these little paint chips are like bullets.
Yeah, because they're going supersonic speeds, right?
Yeah.
Like they're falling at terminal, like to be in orbit means something is falling around the Earth and missing constantly. So it's falling at escape velocity for the Earth.
It always looks so peaceful, doesn't it? And the reality is just like, it's like, ah!
Right, exactly.
But it's always like, da, 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 da. When the reality is, it's like, just, wow.
The Earth is like this little teeny tiny little pebble in this entirely hostile universe. It's like the upside of space tourism is that maybe we can get a bunch of very rich and powerful people to realize that our planet is small and fragile and delicate, and we are all stuck here together, and there is no plan B, and if we cannot maintain habitability on the Earth, we will die anywhere else. Going somewhere else is just death. It's just terrible death.
That's why I like the robots going. I feel like it doesn't feel like a job for bags of chemicals. Like it feels like this is a job for robots. Let's go. And I love the idea of you were saying about the science being available to everybody. I mean, the idea of being able to go to another planet without actually having to go to another planet probably makes more sense anyways.
That's why we have Malps in Stargate.
That's it, Malps. The Malp. I love the Malp.
Very legitimate reason.
Malp on a stick.
Malp on a stick.
That's it. Yep. I malp on the stick all the time, by the way. That's like, of all the things that I learned from Stargate, I will freaking tape a camera to anything. And we had the roof to do. I had like a big stick up there with the camera on it. I love malp on a stick. Yeah,
absolutely.
real life volcanologists should spend more time doing that same basic premise. I was originally did volcanology and I moved to landslides for my disaster specialization, in part because volcanologists have this horrible culture of going towards the erupting volcano and then occasionally getting caught in an eruption. So they have like the lowest life expectancy of any scientist. And I'm like,
wow,
no, I am done with this. This summer they're like, hey, just go camp out on the side of a live volcano to monitor the eruption. And I'm like,
what could go wrong?
But what about all the gas and stuff too? Like even just like the chances of like being poisoned as well is not a big issue.
Oh, yeah.
There?
It's just terrible. And that we can.
I'm not sure I would have then jumped to landslides personally, but I would have like gone with something like, the science of sleep.
I like working with disasters. It's one of my earliest childhood memories is sitting in Marin Headlands watching San Francisco burn during the 1989 Loma Prieta earthquake, the first televised earthquake.
Wow.
So that was like a very like superhero origin story of, okay, I will never be this helpless again when my city needs me. As like, a tiny little small child drawing crayon drawings about like, I will save the city from earthquakes. But it turns out landslides.
Yeah, landslides. It's a good one, especially in Vancouver, in that area around BC. Yeah.
Oh yeah, we've got all these like baby volcanoes, so like rotten, sloppy rock that's all layered like that. Then glaciers came through, chopped the toes off everything, so they're unstable. Then we get a lot of rain, and then they get shaken by earthquakes. So you're just like,
yeah, and you burn down all those forests. There's nothing holding that soil in place. Either, right?
Yeah. Odds of death by landslide are 1 in a million per year, pretty much everywhere in the world, because that's how much money we're willing to spend to stop you from dying in a landslide.
Toronto, we just pave everything. It's fine.
No problems with that.
Yeah, we just pave nature. Pave nature. It's the problem is solved. Yeah.
Well, it won't grow back.
So out in Eastern Canada, we have this really cool thing called quick clay, which is what happens when you had old ocean floor that it's no longer ocean, now it's land. But it means you have clay that has salt in its structure.
Right.
And because it has salt in its structure, if you get it wet, it will suddenly collapse and turn into a liquid.
Whoa.
Right.
So there's like this amazing documentary from the 70s of Risa, Norway, that is like the most 70s documentary ever, with everybody in their big, cute mustaches and tiny little short shorts. Highly
short
recommend
shorts. I love the short shorts.
It's great. But Eastern Canada has that as well. So you can have quick clay slides. So if somebody's like really careless with, say, piling up a bunch of dirt in one place and overloading it, it can collapse the clay structure, and then it turns into a cascading failure where the entire earth just goes ooh, as a slow moving but implacable landslide that just eats more and more ground and turns it all into a liquid as it goes. You can go on like a 1% slope, so you're standing in like a field being like, how is the ground moving?
So Mika, where's the safest place to be now? If you could choose anywhere in the world right now, given what's going to happen in the next, 30 years or something, where would you live?
Well, I'm in Vancouver for good reason.
Oh, you like Vancouver? Do you think that? Yeah.
So one of the things that's happening in Vancouver is that, so as climate change is happening and weather patterns are shifting, as Australia gets hotter and drier, a lot of that rain is coming to Vancouver and getting trapped in our mountains and coming down. And there are problems with too much rain. But I really like the idea of having just a lot of fresh water.
Fresh water is much better than drought.
Yeah, we had like the itsy bitsy teeny tiny problem of giant earthquakes, because one plate going underneath another is stuck. When it eventually goes, the last time it happened, it was like a Mag 9 earthquake that sent tsunami that flooded chunks of Japan. Like, it was bad.
Right. Yeah.
And we think that's going to happen sometime soon-ish.
Yeah.
So that bit isn't so good. And the whole heat dome was also not so hot.
You got to get yourself a Great Lake like us. We just got a giant body of fresh water. It's fantastic.
It's any large
they
body
just pollute
of
the
water
crap
is a
out of it.
temperature regulator. But everywhere has disasters. Is what disasters are you comfortable with? I'm familiar with earthquakes, so I like the West Coast. I get really freaked out when there's like tornadoes and hurricanes and like any sort of storm that has a countdown to doom. Like, in 5 hours it will hit. Get off the roads. I'm like, nope, I'm out. We're done. We're done with this.
I just like tracking things from the basement. I feel very, and I'm sure this will flood at some point too. So there you go. I say that because I installed the sump pump.
Oh, floods and fires, most common disasters everywhere. But it's okay. You can up your odds of surviving a disaster by getting to know your neighbors.
Oh, that's true.
Way to increase your odds of survival.
Be nice to your neighbors.
Yeah, because so if things go terribly, terribly wrong, the first responders on scene aren't the police or the firefighters or the paramedics. It's the people who are physically closest to you, which means your neighbors. So if you can have good relationships with your neighbors, if you throw community block parties, if you do daycare pickup exchanges, if you have like dog walking.
Wait, I see. Well, you're saying I've got to be
whatever.
nice to people to survive? God damn it.
It builds community resilience. It's like putting little like coins into the piggy bank of goodwill that you smash open in case of disaster.
But I've been working so hard towards being the get off my lawn guy.
Yeah, unfortunately, if you want
That's
to
okay.
have
My
that,
wife's
like,
nice.
bump in your
Maybe
survival,
my wife is nice enough for 2 people. So there you go. Yeah.
She'll survive, and you will by association.
Right. Exactly.
Oh my gosh.
Yeah.
I have something that David is very familiar with, and probably you as well, Mika. Oh, well, yeah, I'm dealing with that.
Ooh. Nice.
So this was the MacGuffin of Atlantis. How much do we have charged in the one that we have, and can we get others? Mika, how feasible is vacuum energy sustained in a battery of this type? How possible is that? And what are the odds we'd be destroying someone else's reality if we tried to do it?
So this is that whole the 0 point module,
Yes.
the ZPM.
Thank
the whole
you,
idea is to have,
ZPM.
exactly. Come on, we're doing the Canadian Science Hour
Of course.
No, there's only one way to say it.
Exactly, ZPMs.
Yeah.
So it's you need to have your negative energy density, which, as I said, the science checks out, the math checks out, the physics is totally golden. The engineering is just a little itsy bitsy wee
These
problem.
engineers, they've really got to catch up.
Yeah.
No, I know, right? So either you can take a vacuum and suck more out of it in order to make it more vacuumy, or you can take something that's at absolute zero in Kelvin, so literally the definition of cold, and chill it into a negative temperature that considering 0 Kelvin is when nothing is moving and heat is movement, that's a
kind of difficult.
Tiny
a little difficult.
Tiny engineering problem.
My little desk fridge isn't going to do that.
Probably not. No. But I mean, like, so we're also constantly talking about Nequadria, so the geology, right?
Yeah.
And we want to find the energy density from it. And I have spent so long being like, okay, so what would how do we have the mineralization of this? What would the characteristics be? We know they're trigonal crystals, so we've seen them a couple of times. We know their cross section of them. We know they amplify energy, which is a little bit like a Kyber crystal in Star Wars. So what would its characteristics be? And so far, I figured out that Nequadria is on the do not lick list.
I suspect so.
There you go.
Yeah,
Nequadria or Anaquita? Nequadria is the more specialized version of it.
Yeah, like both of them are on the do not lick. Like refined, unrefined.
David, just don't lick either of them, okay?
Okay, I just want to be specific.
Yeah.
So the problem is, because they amplify energy, there's a good chance that they're gently radioactive. And that turns into a problem because they glow, right? And that we use them as an energy source. So it could be this radioactivity. It could be fluorescence, because there's a lot of rocks in real life that grow. It could be piezoelectricity, or it could be something else. Like quartz, no problem. Quartz is piezoelectric. If you smash quartz, it glows. And quartz is like, your window is geochemically the same as quartz.
Like glass?
Although if you smash your window, like if you smash it, it won't glow. So please don't take that experiment at home.
And sorry, Jane. Mika said it would glow.
Exactly. Like fluorescence is any of the rocks that glow under UV light. So like fluorite, literally they're named for the same thing. But anything that's radioactive, even if it's just alpha emitters, if you lick an alpha emitter can be blocked by your skin, but if you lick it, you're ingesting it and suddenly you're creating problems. So just no go, don't do it.
I like the way that licking has become a real issue for you.
It is.
This is what happens when you have a child, isn't it? It's like you start worrying about what people lick. Yeah.
People got really weird about the rock licking scene in Star Wars, where the little foot soldier goes lick and goes out salt, and people are like, "What? Why would they do that?" And I'm like, "No, that is it's geologic fan service right there." Because I went to the Great Salt Lakes in Utah, and I went out into a field of little white crystals along the edge of the lake, and I scooped down and I licked it like instinctively. That is what I did. What else am I going to find? Of course it's salt. It's the Great Salt Lakes. It's in the name.
Right.
But it's such an easy way to identify salts. By the way, you should not actually lick the Great Salt Lakes because there's been so much industrial things happening there. There's all sorts of heavy metals and toxins in the salt. So, it's a bad idea to lick it. I did it anyway.
For science, though.
It was fun.
Lick for science. There you go. Yeah.
Exactly. No, I don't think none of my rocks currently in front of me are ones that are useful to lick. I was just checking. I chose poorly.
Mika, in Universe, Destiny was way out there in the cosmos. If she keeps traveling in one direction, like the surface of an expanding or contracting balloon, will she eventually come back around to where she started?
So we got to do the cosmic microwave background radiation as a plot point in Destiny.
Correct.
Which is really, really exciting to me because that was my very, very first research project as like a wee baby proto-scientist, was looking at the cosmic microwave background where, so Big Bang happened, everything goes exploding outwards. As it explodes outwards, it cools down. And 300,000 years after the Big Bang, everything cools down enough that atoms could form, that electrons and protons and all that could like clamp together. And so it went from being this big plasma mess to a transparent, clear universe. So there's a wall of static at 300,000 light years after the Big Bang. And because nothing can travel faster than light, then the largest structures that could be in there are 300,000 light year cone across. So if we look at the shapes in the static, we can find out what the shape of the universe is. And when I was doing this back as my like wee baby scientist phase, we had gotten the critical number of what the beginning of the universe looks like, which means what does the end of the universe look like, was it's a different path if it's less than 1 or greater than 1. And our answer was 1 plus or minus 1. We were just like, oh, this is useless. And to bring it back to Stargate, one of the times where McKay was visiting Destiny with
the one
Eli,
and only time,
they finished solving the plot related science and they're standing in front of these sets of equations and they're arguing. And they're arguing about what is the shape of the universe and what does the beginning and end of the universe look like. And from that is talking, the implications are things like, what is dark matter? What is the exact proportions of regular matter, dark energy, regular energy altogether? What is the shape of the universe? Are we going to eventually end in a big cruncher, like forever expanding outwards? All of that was debating about the cosmic microwave background radiation. And David Blue actually had me teach them just enough science that they could decide which side of the argument their characters would be on.
Right. I remember
David
that.
Blue saying expanding forever and David Hewlett saying it would crunch back down.
Yeah.
So Eli
I'm
was
big
right.
on crunches. Yeah.
Yeah. Gotta say Eli was right, and we did not know that for a couple more years afterwards, which is,
Okay, I didn't need that. I didn't.
So it's not going to contract. It's going to continue to expand forever.
Faster and faster and faster, and we don't know why, because it's dark energy. And what is dark energy?
We don't know.
Yeah.
And most of our universe is made up of it. Right.
Yeah.
But wait a second, why would McKay think it was going to crunch then? If it was wrong?
Because he didn't know at the time. But he's got good company because Albert Einstein thought there was going to be he actually named it his biggest mistake to actually have this number at all. He was like, I should have just set it so the universe never changed. And then Hubble did the experiments that saw, and that all of his computers crunching the data and the numbers, but Hubble's the only one who gets credit, saw that the universe was expanding. So then Einstein changed that number again, the cosmological constant, in order to match the Hubble expansion. But then it turns out it's actually expanding faster and faster and faster and faster. So he was wrong yet a third time. And I think that McKay would be pretty happy to be in the company of Albert Einstein for getting things wrong.
He's okay with that, yeah. And given what he knew at the time, I think,
Exactly.
He can only work with the data he's got. I mean,
exactly.
So can we infer that because of the acceleration of the expansion of the universe, that Destiny would not come back around to Earth in time?
Well, Destiny, the universe is very, very, very big, and Destiny, last we checked in, was about to leave the Milky Way. And there are a very, very long way to go. Like there's more galaxies in space than there are grains of sand on the beach.
Mm.
Although we're about to see more of them with the new space telescope that launched, the Just Wonderful Space Telescope, JWST.
So tell us about this. What's going on with this thing?
And so it's the replacement for the Hubble. But the Hubble is still working as much as it can. And it's really, really cool. And that has like these origami lens. So a mirror for the telescope tells you how big and how far it can see. And instead of having just one mirror, it's like this gigantic mirror with all these pieces that had to unfold and then like wedge into different ways. And
it looks like the main deflector on the original Enterprise almost.
Yeah,
it's gorgeous.
It's
it really is gorgeous.
Wow.
It's so beautiful. It's so beautiful.
And fragile. I can't get over how fragile it is. Like, it's just like this.
And we were like,
that it works.
It took forever to actually get built and launched because it's like 15 years late by the time it launched.
Well, but didn't they also add stuff? They added stuff that wasn't originally, didn't they? Like the infrared thing wasn't even supposed to be there, right?
The science got better over time and like the funding changes, and then there was a bunch of political stuff as well. But one of the problems that we had to be like careful about is when you're getting it from where it was built to where it launches, you send it by boat. And they were worried about it getting hijacked by pirates.
Really?
If you're on the high seas, yeah. Can you imagine ransoming this thing?
Telescope mirrors before, as they got hijacked and ransomed the telescope mirror. It's a thing that actually happened, just not to this particular telescope, but it was a fear.
Wild.
Yeah, keep that one off the books when you're transporting it. To let the manifest.
If you ever want to see your telescope again, you'll send $1 million to,
And then what are you gonna do? Of course you would. They're gonna smash this thing to pieces.
Yeah, so that was one of the fears. And then once they got it to the launch pad and they like hooked it up all to the rocket and everything, they had to delay launch. One of the things that went wrong is that the locking bolts holding it in place slipped. So,
you don't really want that vibrating.
Dangling. Just, oh man, don't drop it. Don't drop it.
Oh God. Well, and there was that, I love that little zone before they actually got to test it where they're like, this could be like $1 billion we just threw into space. Right. Like just, Yeah.
And like it's still being tested and coming online, and like they're doing all the test images and all that. But so far, first light has actually been better than anticipated. So it's performing better in real life than our models said it would, which is incredible. And I'm really, really, really hoping we'll get a new version of the Hubble deep field image. So at one point in time, a scientist booked time on the Hubble to go point at the most empty patch of sky they could think of, and just went just photograph that. And that's where we get that image of like all of those galaxies is just from looking at the empty spot in between stars. And I really, really, really hope that James Webb, that the
JWST,
Just Wonderful Space Telescope, I really am not happy with its official name, we'll get to do a version of that as well.
How much clearer, what percentage of resolution is it greater than Hubble? Is it like 200 times, 1,000 times?
So they can't actually do a direct analog.
They can't do it.
Lineup of them because they see different things for different purposes. So part of the purpose of the JWST is to try and identify things like atmospheres around planets in other solar systems.
Wow, so, it can see
looking
that?
Looking for life.
That's the hope. That is the hope.
We're gonna if they can do that, they can like take pictures of aliens reading their newspapers in their backyards.
Well, I'll try and find things like what are the if we can only look at things based on the light from really far away, like we can't go out and poke anything. Then
or lick it.
What chemicals? Yeah, exactly. What chemicals would tell you whether or not there was life there? So you want to find things that have that disappear quickly, so that they have to be constantly regenerated. Would be one way of looking at things. So really dynamic atmospheres, which could also be geologic activity. Like there's trying to figure out what is the signature of life when you only have one little planet to base everything on. Is you're like, well, we've already learned that all of our original theories of planetary formation that were based on our cute little solar system were completely wrong. As soon as we started finding other solar systems, we're like, let's throw it all out and try again. Because we're like, hey, the original idea was the really dense stuff goes first, and that's why you have the rocky planets, and then like the really light stuff is farther out, and that's why you have Jupiter and Saturn and Uranus and Neptune all fluffy out there. And then we started finding things like Jupiter, but in the orbit of Mercury.
So we were just wrong about how they'll organize.
Like just shred it, throw it away, start over. So yeah, we'll find out. We'll find out so many things, and I don't even want to guess at what we'll find out, because whatever it is going to be so much cooler. And I mean, these are the times it's really fun to be able to work in sci-fi, because to bring it back to Stargate again, one of the challenges in Stargate Universe was at one point, they asked me for an astrophysical big baddie that could kill everybody every 22 minutes. And the original idea was, what if we just had a pulsar that was going really slowly? So a pulsar is like a lighthouse of death in terms of high energy particles coming around. And they go out, the jets go out either end, and as it rotates, you get the little flash come past. But pulsars rotate on like the millisecond, not 22 minutes. So if you're just slowing the pulsar down,
sucks for TV.
Well, and it's also going to really slow down what the electromagnetic field is doing. So instead of getting like death rays, it's going to be like if you had fridge magnets and we're doing cartwheels. You're generating an electromagnetic field, but it's not going to kill anybody. You're not even going to notice it. So instead we went, all right, how about we have a starving pulsar, one that's just on the brink of being able to like produce those jets and not, and then we give it a feeder star nearby, like just a normal regular star, that as it gets close, the pulsar greedily grabs its gas, gets a little bit bulkier, spits it out, going flash, 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 and as soon as that star goes away again, then it goes quiet, and you can put that star on a 22-minute thing. And we'd never seen anything like this in real life, but you know, it checks out, right? Like the astrophysics makes sense. Why couldn't you have a system like this?
It could be.
So that's what we did in Stargate Universe. And then 3 years later, astronomers found one in real life.
Sweet.
So but the rotation was it was like 44 minutes or something like.
Yeah, like the timing was different, but the mechanics were the same.
It was more of an HBO show than a network television show. The timing
just extend it all out.
Yeah. Or feature film, maybe. Yeah.
Mika, about the aliens, let's say we do have a space vehicle that can go out there and come across someone way out there. Malp. What are the odds that anything out there, especially now that we know that solar systems don't even organize like ours does, that these guys, gals, things that we encounter, what are the odds they would look remotely like us? Is there
carbon-based?
Yeah. Is there a design logic that's feasible given gravity, atmosphere, and an Earth-type civilization, or is it all just anything goes?
Well, what I want to do before having that is I would like us to go to Enceladus or Europa or any of the other icy moons, and go digging underneath the surface and see what we find, because we have found life everywhere on Earth. We have found life in the clouds. We have found life 7 kilometers underground in a mine shaft in solid rock. We have found life sealed underneath Antarctica in Lake Vostok for tens of thousands of years. Literally everywhere we have found life. So I would like to send little robots around and see is there anything living in the clouds of Venus? Is there anything underneath the ice sheets of Europa? And
Io, something's going on there.
Like Io is just incredibly volcanically active, but you know what? There are extremophiles who hang out in volcanoes. They're there. So I would love us to do a better survey of that, but right now we're held back a bit by planetary protection. So planetary defenses protect the Earth from everything else. Like every year there's big multi-agency practice runs of what happens if we see like a giant asteroid coming towards Earth. The world, like the only
we call Roland Emmerich
disaster.
Absolutely.
Exactly. Like any of those. Can we do anything like Deep Impact or Asteroid or whatever, Armageddon, in order to move them so they don't actually. Yeah. So that'd be planetary defense. But planetary protection is protect the rest of everywhere else from our nasty Earth germs.
Right.
And that's why like the Cassini mission around Saturn, when it finally ended, we crashed it into Saturn so that we didn't accidentally have our nasty little robot covered in like human sneezes and everything
Mm.
hit one of the ice moons and contaminate it. Because how terrible would it be to find life on another place and be like, oh, we brought that with us?
What about the materials though? Like, I mean, is there any chance the materials could interact with stuff? I mean, we're still polluting to some extent, are we not? I mean, we're still throwing our trash on other planets.
We're just kind of picking which ones we're willing to do that. And like Mars is turning into an entire like robot graveyard at this point.
Well, the fact that it's hard to get off our own planet at this point, given the amount of trash we've got revolving around.
Oh yeah. And then we've got like, we're just adding the mega constellations up there and entirely destroying the concept of having stars and a night sky. And we're just doing that because a billionaire wants to. And it's, I would have thought that stars were a human right, but no.
That's interesting, isn't it? Because they're saying that Starlink is basically going to change the ability to do any of the astronomy photography and stuff. I know that was one of the big things they were talking about.
No, you see lines across everything now, and there's just going to be more of them. And then because one billionaire can't do things with another billionaire getting all competitive about it, Amazon's also been approved to do their own mega constellation. So let's have two of them up there, and then they can crash into each other. It'll be great.
Well, we got fantastic. You heard about Steve Wozniak's
what's he doing
project? He's got a company that tracks space junk and is looking at how they can start clearing it up.
Wow.
Yeah, like he wants like some kind of a system that can like either net or but somehow start cleaning it up.
But it's like some of this stuff is moving so fast. I mean, you would have to have some kind of it would have to be a super net to stop this stuff.
There are
or moving as fast as it.
Yeah.
There's definitely experiments about doing it, and that there's some test projects. But again, it's that concept of we have the capacity, we have the scientific method, we can do cause and effect.
Right.
Just do we have the will and the interest in it? And humans are not really good at anticipating disaster.
We suck at scheduling. Yeah.
Like we're really bad with that. Like, low likelihood, high impact events. Everyone's going to win the lottery. Nobody's going to be alive when the big earthquake happens.
Right.
Or climate change.
Or a pandemic hits.
It's worse. Or that we no longer have stars or whatever else. Yeah.
But I like to think that whenever I get too low on this stuff about what a miserable virus we are as a species, there's also the fact that I still have this perhaps stupid faith in our ability to adapt and our ability to innovate. Like, I feel like technology, while it has definitely made huge issues for us, I still believe that it is the solution.
Agreed.
To all of these. As you say, we just need to spend some money on it, right?
Right.
Oh yeah. We have to have political will. We can do anything. We just have to decide
when does that
we're
happen?
gonna do it.
Like, that's the question, I guess, is like, when does that happen? I'm not sure what more we would need.
I was a lot more optimistic before the pandemic happened.
Yeah.
Like, I totally had like this core idea that at some point we have our basic decision to collectively work together. And now we have all sorts of debates.
Well, or the invasion of Ukraine as well. I mean, just with the fuel,
yeah.
I was feeling pretty good about the fact that we were looking for green alternatives, and now, of course, it's just like, how do we start digging up more oil? So I mean, but again, like I say, I feel like my father talks about he's not a climate denier, a climate emergency denier, but he says I remember reading articles about London, England, back at the the horse-drawn carriage days, about how there were these doomsday things about how London was going to drown in horse poop. That if at this rate it was going to be everywhere. It was, and of course, then now we have cars.
Right.
You know what I mean?
We think our way out of problems, though. I mean, London's
that's the hope.
Aqueduct system is. I remember reading something about how they installed the sewers. I mean, it was just a marvel of human ingenuity. So,
well, in the hopes we're doing carbon capture and stuff now. Yeah. Like, I hope there's ways around it, but I do worry a bit about going to other planets when we haven't really quite figured out our own yet, have we?
Well, it's that whole concept of Earth is easy mode, right? Like if you cannot maintain a habitable environment on Earth, you will not be able to artificially create a habitable environment on other planets.
Oh God, I didn't even think of that. Of course.
And there's also this concept of, okay, so we have some billionaires who want to go do space exploration and all that and go like, let's do commercial private tourism colonization of Mars. And first of all, like, well, colonization, there's some issues with that.
Yes.
But the second chunk is, all right, I've worked mining. I have made the world a worse place upon occasion. And I've worked in mining towns. And the labor history of mining towns is really straightforward. The whole reason we have unions is because of coal miners and like the whole concept of living in company towns and the shortened lifespan and the idea that your boss can like control your groceries. How much worse does that get when your boss controls your access to air, heat, water, and food? Like
the whole vertical system.
Protection from radiation.
So the whole, I am at this point, I'm feeling actually somewhat optimistic at the wave of unionization happening in the United States. That is one of my like, hey, this is less terrible than it could be. It's like, maybe we can get a little bit more socialization going on, you know? Turns out it's,
but we do have a tendency to larger
socialist is a naughty word. It only really makes sense if you're incredibly rich. For everyone else, it's actually really nice to have public goods and services and a safety net and like healthcare.
As long as it's run. I mean, again, the issue I always have is just that as soon as you get large groups of people run by smaller groups of people, there's always issues, right? I mean, that's the frustrating thing. And again, maybe technology will allow us to change that. I mean, you know.
The internet has just been a mind-blowing thing in terms of, you know, everyone getting a chance to say what they think online. Whether or not you agree with it is something else. But I mean,
as long as you're not in China, Russia,
but even then with VPNs, you know, so just getting the technology out there.
There is definitely issues in terms of things like, so I clearly have an interest in false news and misinformation and the erosion of the concept of expertise. Like I work in disasters. My specialization is in disasters. I can tell you a whole lot about landslides. I can tell you a lot about like disaster communication and socialize and like how do people respond and interact in it. But there are other people whose literally their entire focus is on how do you get evacuation orders to be obeyed, that they have spent time on that specific exact problem and figured out things that if you have a woman giving the order, you're more likely to have compliance than if you have a man giving the order, because you can like take out the toxic masculinity aspect. And if you have someone older giving the order as opposed to someone younger, you get more compliance because older people will dismiss that young whippersnapper of not knowing what they're talking about.
I do it all the time.
Like ideally you want like your most gray-haired little old lady on the radio being like, the storms are coming and batten down the hatches and hide out.
Right.
And then you
please, dears. Yeah,
exactly. It works way better. There's a reason why all the little emergency voices in the like test pilots are all
they're all female.
They're all women's voices. But then you've got like the cultural aspects as well, where it doesn't work to have the Prime Minister of Canada giving an order about flood evacuations in First Nations territories, because we got a long history of genocide in Canada. So you have to go through the tribal structures instead. Like this is all stuff that we know and that we can use if we just listen to people who actually are experts about it, and expertise has value. And that is really like, there's amazing things in that you can go out and get access to experts really easily right now. Like the number of people who show me their rocks and go like, I found a pretty rock, can you tell me about it, is amazing and wonderful. And I'm so glad to be able to support that curiosity and like let people engage with the world around them and practice their observation and all of that. But it also means that because there's such a flat threshold, that all voices can be treated equally, when no, there's definitely like expertise should be listened to just a bit more on things.
What do you think's changed that?
Relevant.
Why is that changed so much? Is it social media?
There's a lot of reasons for that, and that is getting way outside my lane to try and go on. It's actually my brother worked on that and to some extent. But there's a whole lot of things like false equivalencies. So when we do how we do media coverage, right now we're seeing a lot of journalists get switched onto the climate beat who don't have the background in it, because like media is paying less and less and less. So you just take whatever you can get money for and write your articles, and you don't have to have that beat expertise, that like depth of understanding. And so you're stumbling all over it. We saw a lot during the pandemic of there are ways to talk about vaccines that increase likelihood of people getting vaccines. But we're having all sorts of reporters who've never done health reporting ever, who are like looking at a study of 5 people who are all like a particular demographic and being like, this is the thing that tells us all we need to know. Like there's
well, the math skills too, right? It's just this, you're dealing, especially when you're dealing with very large or very small numbers, people just don't have a concept of it. I mean, I struggle with that myself, and I'm actually interested in it. Whereas most people, I just think go like, where they just accept percentages and random statistical data that comes from nowhere. Yeah,
like I work with numbers all the time, and I can't actually mentally, like, dealing with 20% or 1 in 5 odds is challenging. Hello, puppy dog.
This is Huzzah. Yeah.
Hello, Huzzah.
There you go.
Aw, there's Huzzah.
Yes.
Then I have to give the best disaster preparedness tip, which is make sure you always have a selfie of you with your pet. Because if there's a disaster and you get separated, that is a way of doing identification and also of establishing ownership for reunification. To be like, yes, this is my dog.
This is my disaster, though. This is the disaster right here, I think.
I just figured that's a nice little bit of disaster preparedness. People often get overwhelmed by the idea of preparing for disaster and go, well, I have to do all of these things and it's too much, so I'll do nothing at all. And the answer is no. Do what you can. And anything is better than nothing. And literally just thinking things through increases your odds of survival. So if you have a pet and you're watching today, please take a photo of yourself with your pet and be like, yes, I have done my disaster preparedness improvement for the day.
Absolutely.
It's funny because my family would laugh at me because I would do like fire drills and things, because I was just like, well, what do you do? Like, if there was a problem, I don't know, like, I don't want to work it out on the day.
Correct.
You know what I mean? Like, let's all just meet here and we'll just, there you go, we're fine, you know. Baz is excited because I said, yeah, you could break that window.
Given this circumstance, yes.
Yeah.
I have some questions submitted by fans. I am so thankful we've got 250 people watching today. So thank you all for tuning in. Yes.
Who are you? Shouldn't you be at work?
These people are curious.
Saturday.
Yeah.
Absolutely.
You're right. Good point. Yeah.
General Maximus says, a question for Mika. Your excitement and enthusiasm for science is awe-inspiring. Have you ever wished technology existed so you could transfer your consciousness to AI? So you could live for longer and continue to spread your knowledge to more people?
No, I like being me. I like the very humanness of things. I like that we're fragile, squishy creatures in this giant hostile universe, and we got to help each other out and have that connection. Like that to me is really, that is motivating in itself. That is
I'm the total opposite of that. I like totally want to be mechanical.
Yeah.
I don't like this big bag of squishy chemicals. I want to be a, floating around in a bucket somewhere with surrounded by a robot.
Well, I mean, I think that also an element of my privilege is showing. If I had chronic pain, believe me, I'd be like, okay, I am a biochemical mess. Like that is what this is. It is chemically.
Yeah, my shoulders hurt. Maybe that's it.
Let's just get out of here.
Yeah.
But no, I mean, I like licking rocks and petting yarn, and like I like the very tactile exploration of the world. It's one of my favorite aspects, is being able to like poke and touch and feel.
That's so funny though, because we both have similar sort of like love of this stuff. Obviously you have the knowledge, I just have the interest, but the you have the skills, I just have the love of it. But I've always been obsessed with the technological side of being human. The idea that I love this sort of the man machine combination.
I think what comes down to the question of how much could you transfer? You know, how much of you would go? You know, would your tactile experience go, or were we just talking about a brain in a machine? Mika?
Well, we also already have augmentation, right? Like I normally wear glasses. I'm doing contacts right now, so I've got that going on. There's people who have artificial limbs. I mean, there's a huge number of people with uteruses who have implants that are literally, they are now cyborgs. If you've ever had an IUD, congratulations, welcome to the cyborg core.
I got hearing aids.
Yeah.
With hearing
Well,
aids,
glasses is in some sense cybernetic. So
it's an augmentation, right?
Yeah.
Like it's to make things better. And I mean, if I were time traveled back, I would be one of the people who was eaten by a saber-toothed tiger because I can't see very well.
Right.
Like I have a focal range that's in the centimeters.
That's
I
like
am
Jane.
so
It's like she was
nearsighted
looking
that
through
I
Coke
can't
bottles.
see outside
Yeah.
of arm's reach.
Huh.
So
the number of people who are alive today because of refrigerated insulin. You know, it's just it's extraordinary how technology extends our lives now. It's ridiculous. So
well,
it's
and very topically, it's how many babies are still alive because they have access to formula. Because breastfeeding is hard. Chest feeding is incredibly hard.
Yeah.
And like the nutritional components of this. And that right now we have some serious freaking issues on that one.
I know there's like isn't there like you can't get access to specific stuff now. Formula shortages, right?
Yeah, and that like the amount of lack of information about this, where people are like, "Oh yeah, just start breastfeeding again," and you're like, "Well, first of all, it's not just a fountain.
It's not available to everybody.
Yeah, you don't have a switch.
Second of all, if you're in the United States, you have 6 weeks before you're back at work. Which
Seriously?
means that's it. They only get 6 weeks.
Oh my God!
A birthing parent must be back at work. And then you have to be able to pump at work, and pumping is hard. And then a lot of workplaces have ridiculous conditions for it, or illegally deny access to pumping, which can just completely disrupt the entire supply. And not everybody can produce milk in the first place. And then not every baby can eat every formula. Like there's all sorts of soy and cow's milk are in a lot of formulas, and yet soy and cow's milk are 2 of the top allergens. So you got to pick just the right one. It's got to be the right brand. If you try and switch too quickly, you can cause all sorts of problems. And it's just the amount of misinformation is horrifying. And all of them, like all these parents in Canada right now, all the parenting forums of like little babies are all like, "Oh,
yeah, what do we
I feel
do?
so bad for our Americans. Could we like ship them formula?" Which we are not allowed to do.
Well, we're not allowed to do that?
Can't send it across the border. It's a restricted.
Wow. I know we're trying to reach out to Ireland.
Because it's protected?
So.
Because there's different regulations for food safety in Canada, which is also why we don't have a food shortage right now, because we have different inspections. And so we don't have like a single plant that was continually inspecting the formula with like salmonella and other horrendous things. It's all a big preventable mess.
We used to cross the border all the time.
They're a bad idea.
We used to cross the border all the time because we lived in Point Roberts. And I was always amazed at how on a weekly basis, there would be different declarations of things that weren't allowed to cross the border, whether it was a tomato from Mexico or
wow.
Crazy. Yeah.
Jonas wants to know, Mika, what exactly is 0 point energy?
It's negative energy density. So it is, if you take something that is at if temperature is things moving around, and 0 Kelvin is when nothing is moving at all, and then you make that colder, you have negative energy density. If you have a total vacuum with nothing in it, and then you take stuff away, that is negative energy density. And if this is making your head hurt, congratulations, you have wrapped your head around it successfully. It is that weird and unintuitive. We have never seen it in real life. It's an engineering problem. But the
engineers are taking a beating in this podcast.
Of course. I mean, so I'm a Canadian, right? And in Canada, geoscientists and engineers, we go through a ceremony where we get married to our work. So I have a little silver ring.
Shut the front door. Seriously?
Yeah. I went through a wedding ceremony with my work. My ring has seismic signals and crossed hammers on it. It's a silver ring because I'm a geoscientist. And I had to swear that I would only do what I'm capable of doing, stay in my lane. I will be paid fairly for my work, because if I allow myself to get undercut, I undercut the entire profession, and it's no longer sustainable to have skilled people in it. I will make mistakes, and that's okay as long as I fix them. Like, the vows are incredible. And Canadian engineers take their own version of this, and then they walk away with an iron ring. So if you see somebody with on the pinky finger of their working hand, silver ring is the geoscientist, iron ring is the engineers, and we're supposed to wear it on our working hand so that when we're like signing off on documents, we're reminded of our oath of obligation.
Wow. So for actors, we don't do anything. we make a commitment to lie convincingly on a regular basis.
Oh, geez. Yeah, but I mean, hey, everyone's got their lane.
Yeah, exactly. That's my lane, and I'm sticking to it.
Teresa MC, question for Mika and potentially David too. What organics could possibly use to make a spaceship, like a wraith ship, if any at all, especially here on Earth? Would there be any that would be suited to help, make something that would survive in space?
Well, so if we want to have radiation shielding, the easiest way to do that is to carry around your water. So that would also give you a supply of water, but water is really good at blocking a whole bunch of stuff. So you just encase your ship in like ice, would be a handy thing to do in terms of creating some shields.
Wow.
Not like a skin of tardigrades or something. There's no sort of like.
I mean, if you're coating it in ice, in all likelihood there are tardigrades on it.
Tardigrades in there,
like,
anyways,
we know from past experience that when you duct tape them on the outside of the space station, they stay alive. And a billionaire crashed some tardigrades onto the moon, which I bet are still alive there too. So
we crashed tardigrades on
without permission, didn't tell anybody till after the crash already happened, and it was like, by the way, I stuck some tardigrades on that lander.
Wow. They've just populated the planet.
They're just so small.
They are until they attack us when we show up on the moon.
Right.
Yeah, that's right.
Yeah. I mean, well, we already left like several hundred pounds of vomit and poop, which has been sitting there getting radiated for this entire decades in between. I'm pretty sure there's something growing there that we don't want to know about. It's like unintentional science experiments.
One of my favorite Doctor Who episodes was about these organic, this organic ship that was alive, and I was always fascinated by that. The idea that there was a vessel that grew and protected its crew, by actually being alive, and it was green, so it could use, chlorophyll and all sorts of, it was just a great concept.
Doctor Who's got some good episodes out there, man.
Yeah.
Mika, you kind of blew by this earlier, and I was like, ooh, more information, please.
We got to get Mika out of here too, because she's got kids to feed.
Yes. So are you good for another 15, 20 minutes?
I don't think I can go that, or I can allow the small children to come.
Tell that to the child.
Okay, so you want 5 minutes?
Sounds good.
Okay. Is the wormhole based on a black hole or white hole physics or something more mystic? The one that we use in the show. You said that the specific kind of wormhole that's used in the series was an XYZ wormhole. I forget what you said.
It was a Schwarzschild wormhole with a traversable radius, which means it's a traversable wormhole, so you can go back and forth on it. Schwarzschild is the exact type of formulation of it. So there's a whole bunch of different ways to do the math, and that's the one we pick. It was actually picked by Steve Conboy, who is a string theorist, and he was one of my roommates at the time. I was at grad school at UBC, and Stargate came looking to the campus saying, we need a string theorist because it's the smartest scientist they could think of. And I heard about that and said, hey, Steve, go take the job. Take it. So he worked on Stargate SG-1, and he literally would put his thesis notes in episodes before he ever actually published papers on them. So they published in Stargate first. Then Steve found a pretty girl in a telescope in South America and left. So when Stargate came back, I went, me. Because by then I realized they didn't need the smartest scientist. They didn't actually need a string theorist. They needed a creative and excited scientist. So I showed up on my first day and was like absolutely awestruck. I went around big, huge eyes. I don't have any photos from the first day with any of the actors because I was too nervous.
That's right. You were nervous. I remember you said that.
It was like my first job outside of summer camp counseling. And I was in grad school. I was still technically a student, like an eternal student at that point. And I'd never been on set before, but everyone was like super, super, super friendly and like taught me things like why you don't wear bright, flashy colors so you don't distract everybody. And like,
well, that's a reason to wear them. Just wear them. That's the whole point of it.
For the actors, not for the scientists who are hanging out and back. And just, it was really, really fun. And I got to keep coming back. But yeah, so Steve picked the original wormhole style.
I see.
And I stayed with it because it worked really well for what we were doing.
Right.
So we stayed consistently with that same type of wormhole formulation. And then before Steve, I was actually Kenny Gibbs, the prop master, used his high school physics textbook.
Wow.
So we went from high school physics textbook to grad student in string theory to disaster geophysicist.
Quite the combo.
Quite a ride. Mika, this has been such a treat having you on to educate us about all these goings on right now. This is a trip. I'd love to have you back once again down the road here.
Oh, I just love it.
I feel bad. We have like 4 pages of questions. I feel so bad that I took so much of my time rather than getting to them. So we're going to have to use them at some point.
Save them for next time.
I think so.
Do it again.
And
Why
David,
not?
thank you.
Oh,
so
pleasure.
Much.
Yeah.
Guys.
I love it. I want an opportunity to learn from Mika. Come on. I'm there.
Absolutely.
I'm there.
Mika, we really appreciate all the time that you've given us. And David, could you stay on for a minute and talk about Tech Bandits?
Sure. Yeah.
Okay. I'm gonna let Mika go. Bye. Thank you. Be well. Take
Lovely
care of
to
yourself.
see you. Soon.
Bye-bye.
Cheers.
All right. Tech Bandits. So what's going on with you, brother? What's going on with your project? And I'm gonna adjust the camera in real time here so everyone can see.
Well, what's so nice about it is it's the Mikas of the world I'm looking for, right? I mean, it's the people who are excited about this stuff, and I think I feel like the kids go into school like Mika,
right? Exactly.
Excited about everything and curious about everything, and then that just sort of gets bludgeoned out of them very quickly. So it certainly was for me. You know what I mean? So it's amazing to me to read stuff about about education now, what people's theories on education and stuff, to realize that taking things apart wasn't me just breaking things. It was
you're exploring how the world functions and everything else. It's I took all of my Star Trek toys apart at one point in my life just to see the little sound devices on the inside that made the Klingon bird of prey make noise and things.
How do they work?
That. So
yeah,
exactly.
That's it. I mean, it's it's nice if you can put them back together again sometimes, but I was never good at that part so much. But I was amazed at how much I learned just by pulling stuff apart, and I was also concerned that kids weren't doing it. Like, there's so much. The technology's become so sort of black boxed that it was like, an Xbox breaks, you throw it out and get a new one, and I mean, that's probably part to do with just the sort of the privilege to which I'm exposed, but the idea that you would throw that out was just bizarre to me. I was like, no, you want to take it apart, see how it works. And once kids realize they can do that, it is amazing how excited they get about it. So one of the things I've been trying to do recently is get I'd like to get sort of an educator's perspective on some of the stuff we're doing. So my sister is actually a child development specialist, not the one from Stargate, another one.
Oh, okay.
So I'm going to get her to help me out with some stuff there, to try to come up with a little bit more of a, I don't know, maybe like a little manifesto, something like that, just so other people can start doing this stuff. And I'm also working on the garage so that the local nerds can come in and use my 3D printers and CNC machines and stuff. So yeah, I just because I've got all this fun tech sitting around. I can only play with so much.
Correct.
And the whole point of it all was that, pre-pandemic was that kids could play with it. I don't want to go back into the schools now. I don't see the point of it. It makes more sense for me to have a space that the kids can come to, and the online stuff has just been an eye-opener to me. It's just the idea. The kids wanted to have a Discord channel. They wanted to talk on Discord. They wanted to stream our chats. And it was nothing I'd planned for originally. It was Baz's idea. I started doing it, and I'm like, oh, this opens it up to an entire world. And I just love it.
I think it's one of the things that I'm so thankful for in this new era of that we're moving into, is this learning at our own speed, taking our time. Not everything must be done in 10 minutes. A little bite-sized XYZ. I have a concern as we continue to move forward. There was an episode of Stargate SG-1 called The Sentinel. And in this episode, this was like right after you were introduced. SG-1 goes to this planet where the Goa'uld have taken over because one of our rogue teams broke their security system. And the people hadn't used it, hadn't taught themselves the maintenance of the Sentinel for generations. And they just relied on it continuing to exist without knowing what it was or how it worked. And I watch a lot of our young people now accept these things and accept other devices, and just in general accepting the reality with which it's being presented to them without asking themselves, how does this work? I mean, computer monitors and television still blow me away. How is all that information organized exactly in the right shape and exactly in the right order? What is telling it to do that? If we're not curious about our world, at what point do we lose interest and curiosity in that and just accept that, well, what we have, we've always had and we always will? Because it's not necessarily
look at all the
case.
the COBOL programmers that got pulled out of retirement because around, at the 2000, at the Y2K issue, because they were, and still to this day, there's people pulled in for banking and stuff because these systems are built around an programming language that people don't know.
That's right.
But it's interesting. I mean, one of the things that I like about sort of the future for this stuff as well is that it isn't just the sciencey science. Like there's a as AI gets better at creating simulations for us and finding patterns for us, our skills as humans will become more important. So all of a sudden, that creative side, that the odd perspective on things, the Mikas of the world become far more valuable because they have a uniquely human perspective on this stuff. So
and a desire to share for free the information. Free to the world. For me, it's like, Tech Bandits is more about me learning stuff than kids learning stuff. I mean, it really is. I say that the best, I try to stream at least once a week. It's usually Monday or Tuesday every week. Yeah.
For a couple hours. And I just, I always, the best episodes, for want of a better word, the best sessions I find are the ones when I walk away and the kids have brought up something that I hadn't planned on talking about. Because then it's an excuse to go out and look for something. I mean, and they go like, oh, what is that really? Like, there's a couple of times that there's this kid Wolf Pup in our group who's constantly saying things, and I will say like, well, I don't know about that. I was like, oh my God, you're right.
Yeah.
Like, to me, that's education, because for me, I'm learning stuff. And I don't care. I don't mind being wrong. I'm a freaking actor. I could be wrong about everything. But what do they get from it? They told a grown-up something that they didn't know.
Right. Exactly.
Right? I mean, that's the kind of thing that if as a kid, the idea that I could actually that a grown-up would say to me, like, oh my God, I was wrong. You were right. That means something.
Absolutely.
You know what I
As
mean?
a homeowner, I am really big on self-reliance as much as possible, and the fact that I can go to YouTube and learn how to do X, Y, or Z on my water heater.
I can help you with a sump pump. That's all I've really got. Sump pump's all I got, and I'm very good at demo. My wife would say.
There you go. But these tools are there for those who are curious to go and look. And sure, you can hire a professional to come in and do it. But I mean, if you learn how to do it yourself and learn how to do it at least correctly without damaging anything or taking anything outside of code, there are resources for those who are intellectually curious and go, oh, that was actually kind of cool. And now, what else can I pursue in that direction that I can teach myself or someone else?
The weird thing that I'm seeing, though, more and more is this illusion of knowledge, though, that people will watch a YouTube video and go, oh, I know how to create a nuclear reactor.
Yeah,
it's because they've seen all the information. There's a sense that that because you've seen it, you understand it. And I fall for this all the time. I love tutorials. I do tutorials all the time. When I then sit down to use the software or do the experiment, I suddenly go, oh, but how did you do so it does make a difference. You have to get up and do things. You have to be active in this learning as well. I think it's very easy to sort of kick back and just sort of watch science videos in the same way that you'd watch, I don't know, Fail Army or something. You know what I mean? Like you come out of it, you get a few giggles.
It's so easy to delude yourself.
That's it. That's it. But as you say, it's the collective knowledge of the human race. If I want to learn something, I can go to YouTube, look it up, and I'm fixing sump pumps. I mean, like I love that.
Absolutely.
My dad says that too. He talks about that with the boat stuff because he's got, he bought a hole in the water that you throw money into.
I've heard that's basically what it is.
Oh, I don't know how he does it. Yeah.
God, yeah. I a friend of mine told me once, owning a boat is like standing in the shower with your clothes on, tearing up $100 bills.
Yeah. I mean, I guess my dad's earned it though. So
there you go.
I feel like he had to raise me for God's sake. That's
jeez. How's Kate doing? How's Kate?
Great. Oh my God, that kid is ridiculously cute. And
We need to have her back.
and for some unknown reason, whenever she sees me, she makes fart noises. It's pretty cute. I could not get her to laugh. I tried everything. She laughs at everyone else except me. But now at least we communicate with farts. The language of farts. It's an international. The universal language of farts. There you go. Yeah.
My friend, it is truly wonderful to have you on.
Anytime, man. Anytime.
So where can we go and check out Tech Bandits? Where is that available?
Well, I discovered something else. You break things and then you learn.
Of course.
So apparently, if you change your username on Twitch, it changes the name of your channel.
Oh shoot!
So if you go to David I Hewlett on Twitch, that's where you'll see us. But you know what? Honestly, techbandits.org. That's where I tend to. So that's where I'll probably end up updating stuff. But yeah, it's God, I love it. I love the fact that you could do this. I love the fact that you're doing this. This is like, how are you finding all this now?
Learning something new all the time. I just recently figured out how to add the podcast to all of the audio podcast channels.
Ooh, so you do like an audio version.
There's an audio version.
Oh, I should pick your brains about that, because I thought about doing that with some of the Tech Bandit stuff.
So all you have to do is just port the content over to. I use Anchor. It is tied together with Spotify, and they host your channel for free, and you can actually do little advertisements. And I make I've made like $10 on it. So
sweet. I know there's something wildly satisfying about someone giving like I did. I think I got like $1 from Google the other day, and I was like,
right.
Oh my God, Jane!
I know.
She's like, oh my God, seriously? Like,
no, but I mean, the fact that you can upload something and not have to deal with server maintenance is wonderful. God. So if they're willing to host it, and I can, and you can record your own ad at the beginning of it, which what I did was like show people how to use Anchor to make their own podcast. I'm like, I'm all down for that. So
that's cool.
It's really cool. So yeah, so you just. So it's Anchor.
What about merchandise? You got any merchandise yet?
Well, I am doing. So I have my own merchandise channel. So that's at the dialthegate.com merch.
Yeah, get it in there.
And I just created a new design based on the Wormhole Extreme logo from season 5 of Stargate SG-1.
We need good merch.
I know.
It's like Stargate merch sucks. I have to do a little call out that Barnacles Nerdgasm is here, and he's a wonderful friend of mine who I try to podcast with along with Ox every Saturday. We do tech talk, usually around like 1 or 2 on Saturday morning for me, which is Saturday morning for me.
Yeah.
And he's in the chat too. So everyone should go say
absolutely.
Follow him as well. He's wonderful.
And what's the name again?
It's Barnacles. Barnacles.
Barnacles. How can you spell that for me?
It's BARNACULES.
And is this on Twitch?
Nerdgasm is what he calls himself as well. So
Twitch.com/nerdgasm.
I don't know what the Twitch channel is. You know what? Actually, no, he can't. Of course, he can't post it, can he? I'll throw some links in the
yes,
chat.
Please do.
That's probably the best way to do it.
Absolutely. Yeah. All right. Anything else we want to wrap up on before we get you underway?
No, that's it. When can we do Mika again? We got to have this. That chat was great.
I feel so bad to everyone who submitted questions. We did not get to them. I had no idea we get this much of a response. So I'd like, let's get summer out of the way and plan something for September.
Absolutely. I'm totally in. If you don't mind, I just love it because I actually get to learn stuff. So
that's exactly why I wanted to do this for sure. And she is so exceptional at enthusiastically sharing knowledge, and that's I think what's so cool about it. I would have been like on her heels constantly were she on set on the show that I was working on.
She's extraordinary. I mean, and absolutely, she loves it, and she just makes you love it as well. So
absolutely.
All right, here we go. Let me find Barnacles' channel here.
Okay.
I never say right. I never ever say his name.
Yeah,
right,
if you can post it here, I'll pull it up on the screen.
Copy. Here we go. I'll just post it in there. Can I do that?
You should be able to in the YouTube chat here.
There you go. It's a really long, complicated. I don't know why there's so many but that's definitely go and follow him as well.
Okay.
All
Twitch
right.
Channel David H is talking about Nerdgasm _TV.
Oh, is that what it is?
Yeah,
What?
evidently so here. So yeah, it's a blonde guy, scruffy face.
No.
So yeah, Nerdgasm.
Blonde guy,
TV.
scruffy face. What? Is that,
Nerdgasm
no,
underscore TV.
I don't. Is that right?
Is that okay?
I don't know if that is the right one. Is it? Here, let me copy this. I'm gonna put it in the
not
chat for you.
Nerdgasm TV. That's not me. He said. Oh, okay. That's
All right, here you
Gate
go.
Gabber, my producer. She.
There you go. That's a link to the actual channel. I put it in the Zoom chat.
Oh, my Zoom chat. Let me pull this up here. I do want
There
to
you
get
go.
this.
You got that as well. I've also put it in the
before we go.
chat as well, so it's all there.
Oh.
Question for Rodney McKay: what were your thoughts about management? Let's talk about leadership.
That's funny. Let me see here. Barnacle Nerdgasm. Got it. Okay, this is him on YouTube. Very good. So okay.
Yeah, it's fascinating. He used to work for Microsoft.
Wow.
And has a few thoughts on that.
Okay.
And a few thoughts on everything. Actually, he's a fellow nerd, and I don't even know how we met. But for some, that's right. I came onto his podcast once, and he never got rid of me. It's like you. There you go. I tend to show up on these things, and then you can't get rid of me. It's like I'm like a.
We love
like a cat
having
on the
you,
curtains.
Dave.
Yeah,
absolutely. All right, so we got him a shout out on the show here. I look forward to having you back on for season 3 later this year, and we will bring Mika back if she is willing, if we didn't drive her crazy, and we'll talk soon.
Fantastic, man.
Thanks, brother.
Thank you, everyone. Cheers.
Be well. David Hewlett, Rodney McKay on Stargate Atlantis, NSG-1 and Universe as well. I have a couple of photos that I would like to share. Couple of pieces of artwork that I would like to share from Cell Chat. She sent me these a couple of months ago, and I said, we have a really big episode coming up really soon. I want to maximize the view at that point. Her sketch artwork is just sensational. This is obviously Paul as Carson Beckett. Carson again. This is Nicholas Rush from Stargate Universe, portrayed, of course, by, God's sakes, my brain is doing this to me right now. It'll come back to me. David Blue as Eli Wallace in a very non-Eli type of costume. Let's see here. This is Chloe, of course, played by Elise. Brian as Matthew Scott. I think this one is my favorite. This is the use of color here is just really sensational. So Colonel Young, Shepard, Sam, Tori Higginson, Elizabeth Weir. Robert Carlyle was the name I was missing, of course. And this is a really cool one. Shepard and McKay. McKay holding I think he's holding his Game Boy there, and Atlantis on the horizon in the background. That's just a really cool piece. All right. Dial the Gate is brought to you every week for free, and we do appreciate you watching, but if you want to support our show further, buy yourself some of our themed swag. We're now offering t-shirts, tank tops, sweatshirts, and hoodies for all ages, as well as cups and other accessories in a variety of sizes and colors at dialthegate.com. And from the Merchandise tab, you can click on a specific design to see what items are being offered. Checkout is fast and easy. You can use a credit card or PayPal. Just visit dialthegate.com/merch. And I just uploaded a new Wormhole Extremist t-shirt. So it's based on, if there were Wormhole Extreme fans, I figured that they would be called Wormhole Extremists. So that's available now. My name is David Reed. I appreciate you tuning in. Robert Murray Duncan is going to be joining us next Saturday, I believe let me double check on the time here, 12 noon Pacific time. He played Seth in the season 3 episode of the same name, as well as Melbourne Jackson in season 2. That episode was the Gamekeeper. So we will have Robert Murray Duncan next week at this time. I appreciate you tuning in to Dial the Gate. My name is David Reed. I appreciate my moderating team, Summer, Tracy, Keith, Reese, Anthony, Jeremy. You guys make the show possible. Big thanks to my producer, Linda Gate Gabber Fury, to Frederick Marcoux at Concepts Web. He's our web developer, keeps the website going, as well as Jeremy Heiner, our webmaster, who keeps the site up to date as well. My name is David Reed for Dial the Gates. I appreciate you tuning in, and we will see you next week on the other side.